start the epidemiology section of the PLAB 1 keys. This is the outline and the summary of the things that I'm going to discuss. We'll discuss the incidence, prevalence, absolute risk, relative risk, absolute risk reduction, relative risk reduction, sensitivity and specificity. The first concept mentioned is the number needed to treat. In order for you to understand this concept, you need to understand a thing that is called absolute risk reduction, ARR. Let me explain it. In order for you to understand the absolute risk reduction, I would need to teach you about what is a control group and what is a treatment group. There are many examples available on this beautifully explained website. I'll give you the example number 2. Now you want to test that if a new drug works for asthma or not. So you divide 100 volunteers into 2 groups of 50. One group 50 gets the drug. They are called the experimental group, or otherwise they are called the treatment group. The next group is called the control group, which do not get the drug. They get the placebo. Now let's come to my presentation. Control group does not take the medication. Treatment group is given the medication. That's the difference. That's how you will see that whether a thing works or not, or whether a test is working or not, whether a new drug, whatever new you are trying to introduce to the people, to the healthcare system, you have to go through this type of study. First, you will take the control group. The control group is given a placebo, right? A control group is given a placebo, while the treatment group, also called the experimental group, gets the drug. Then the results will show you how much a drug is affecting. Now here is the example. How can you deduce? How can you know that a drug or a test has absolute risk reduction? Usually it's a drug. Yeah, mostly it's a drug. Absolute risk reduction caused by a drug. That means in a treatment group, because you are giving them, the control group, the placebos, actual treatment is given to the treatment group or the experimental group. So if all are diseased and you give a drug and one of the people gets cured, he gets treated, he is now free of the disease. So what was the absolute risk reduction? Absolute risk reduction. That means risk of disease is reduced by taking a drug. How much it is? How much a drug is effective? How much? Measurement of that thing, that value is called absolute risk reduction. So if you are taking 10 participants, one of them gets treated, what is the absolute risk reduction? Now keep in mind, for every data that you take in epidemiological studies, you need a control group. A control is a comparative thing, because in humans, A plus B is not equal to C. There is a variation. That's why everything is done in terms of percentages and standard deviations and coefficients of variations. Everything is done with respect to something else. So that's why without control group, without control data, you cannot estimate absolute risk reduction or how much a drug is effective, in other words. So you need a control group data, then the treatment group data. Now in this example, it's a very beautiful example. the control group has death in 20% of patients. That is to say, if a control group is taken, if you take 10 people, 2 of them die of the disease. For example, you are testing for the diabetes. You are testing for the diabetes. You have introduced a new drug. You want to introduce a new drug. You have experimentally found a drug. Now you want to check how much effective it is. So 2 people die. If you take 10 people, group of 10 people in a control group, they get placebo, they die out of the complications of diabetes. Just take an example. Now, in the treatment group, you gave drug to all of them, to the 10, and 1 of them survives. Now, this anti-diabetic drug, what is its absolute risk reduction? How efficient is this drug? This is the same example I am explaining in the chart form in my PowerPoint presentation. So, what is the absolute risk reduction? What you will do? The control group data, absolute risk for the control is 20%. Now, absolute risk for the treatment group is 10%. How much it improves? How much effective it is? 10% effective. What does this mean? Absolute risk reduction of 10% means if you give treatment to 10 people, 1 of them gets better. What is 10%? 10% is 1 out of 10 or 10 out of 100. If you give treatment to the 10 people, 1 of them gets better. This is the absolute risk reduction. As simple as that. All the concepts that you are learning is just a manipulation or a little modification of ratios. What is the ratio? What is the ratio? What is the ratio? Now comes the term that we started with. The number needed to treat. What does this mean? Let me explain it as well. Now, as I already told you, everything in the studies, in the epidemiological studies, is just the ratio. So, in the treatment group, you gave treatment to the 10 people, 1 of them gets better. So, what is the number needed to treat? That means how many people you need to give medication to in order for 1 to get the result. If the absolute risk reduction is 10% for some drug, then what is the NNT, the number needed to treat? How much people you will treat and how many people will get resolved of that disease. If absolute rate reduction is 10%, you just divide by 10%. 1 divided by 10% will give you NNT. As simple as that. Now, how much number you will get? Let's see here. If you divide 1 by 10%, you will get 10 answer. How you will get 10 answer? It's 10%. 10% means 10 divided by 100. It's equal to 0.1. 1 divided by 0.1 will give you 10 number. So, 10 people you have to treat and 1 will get improvement. If you give improvement to, if you give treatment to 10 people, 1 of them will get improved. These are reciprocal of each other. Now, if you read the notes, now it will be crystal clear to you for what are the definitions of absolute risk reduction and number needed to treat. Now comes the topic of sensitivity and specificity. What is sensitivity and specificity? It's all in the word. Sensitivity. It's sensing. It's sensing something. Like pap smear. If there is a pathology like cervical neoplasia, the pap smear will detect it. But if something is detected in pap smear, it does not specify whatever it would be. This test cannot specify. That's why it's sensitivity test. Sensing something. But the other term is specification. It specifies something. It pinpoints, sharp, like sharp arrow. it pinpoints that this is there. This sensitivity shows us that there is something. Specificity shows what is that thing specifically. Most of the general investigations like CBC, like chest X-ray, these are all sensitive. But if something comes in CBC, you cannot diagnose based on the CBC that this thing is there. You have to do the other tests. Those all other tests are specific for diseases, specific for those diseases. For example, if serum ferritin is high, you can be damn sure that it's iron deficiency anemia, keeping in mind the other parameters as well. If you find something on the chest X-ray, you perform the CT of that area, then CT is specific. So many tests, most of tests that are high in sensitivity are low in specificity, like these tests. These are the example. So in like here, true positives divided by true positive and false negative. Then specificity is true negative divided by true negative plus false positive. How would you ratify the formula? The trick is these are opposite to each other. Sensitivity contains N. Sensitivity is N, and there are two N here. Specificity is P. Here are two P's. In the bracket, there are false. Opposite to the main. This is positive, then it's false negative. If this is negative, then it's false positive. That's how you can memorize the formula. Then the formula of PPV and NPV are very simple. Positive predictive value, all positives. Negative predictive value, all negatives. But true comes out of the bracket. True is always out of the bracket. That's how you will memorize the formulas. Now what is accuracy? A test should be highly sensitive as well as highly specific. Keep in mind, a test should be highly sensitive as well as highly specific. A test which is highly sensitive but not specific is of no use, because it is a wastage of time and cost. A test which is specific but not the sensitive, that means it only is done for a single disease, to specify the single disease. That means all other disease cannot be detected by that test. What a waste of energy and time. A test should be accurate. That means it has to be highly sensitive as well as highly specific. And there are very rarely those tests which are highly sensitive as well as highly specific. Now let's learn other terms. What are the other remaining terms? The absolute risk. What is the absolute risk? Exposed divided by total. The percentage of people among a certain group who got an event. Now number of events, how many people suffer divided by total number. It's absolute risk. It's just a simple percentage, nothing else. Let's learn from the example. 200 patients you have. 10 of them died while on drug A. 20 of them died while on drug B. What is the absolute risk for the patient on drug B? Absolute risk for patient on drug B. How many of them died? 20 of them died. 20 of them died while on drug B. Okay? Total were 200 patients. So what is, it's simply percentage. It gives you a value, convert it into percentage, that means 10%. That means 10% of the people died because they were on the drug B. Now, similarly, if 10 of them died, risk was 5%. Like in 200, if 20 died, it's simply 10% comes into your mind quickly. If out of 200, only 10 died, 5% comes into your mind quickly. Now, let's come to the relative risk. Here is the relative risk. How will you understand? Absolute risk, for some people, for example, this is the population which smoked and they developed lung cancer, and 10 of them smoked, 2 of them developed lung cancer. Now for unexposed, 10 of them did not smoke, all 10 of them, but still 1 of them got lung cancer. How would you deduce, how would you know that how much smoking is causing how much lung cancer? How many times you are prone to get and catch the lung cancer if you are smoking? How would you know? That term is called relative risk. What does this mean? Absolute risk for exposed minus absolute risk for unexposed. Let's learn by example. Now keep something in mind that I didn't tell you. The relative risk does not give you a number. It gives you a percentage. Okay? It gives you a times value. How many times this thing can cause that thing. So it's not a number. It is a factor. It's a percentage or a factor. It's not a number. Numbers have absolute value. When you divide something, you give a times value or the percentage. So absolute risk divided by, not minus, divided by the non-exposed group. Absolute risk in exposed group divided by absolute risk in non-exposed group. Learn by the example. Study examines the effect of smoking on developing lung cancer over a period of 10 years. 400 people were involved. 200 are smokers, 200 are non-smokers. Now 10 of the 200 smokers developed lung cancer. 2 of the non-smokers developed lung cancer. What is the relative risk? Like I told you. In the smoking group, okay. So you divided absolute risk in smokers exposed is 10 in 200. That means 0.05. Now in non-smokers, non-exposed, it's 2 in 200. It's 0.01. When you divide them, you get a 5 number. What does this number means? This means that smoking increased the risk of lung cancer by 5 folds. That's the use of relative risk and absolute risk concept. Now all other concepts are very simple. Incidence means number of new cases. Prevalence means new plus old. Prevalence means new plus old. That's simple. Now you have to calculate it. Now this is a little bit tricky question. The trick is explained here. It's very simple trick. You read it yourself, you'd get it. Now what is this fuss about the studies and trials? Studies you do for observation purpose. Trials you do for discovering a treatment. Studies are done for the observational purpose. Studies are observational and interventional. Usually the study comes after, whenever it comes after a word, a phrase, that means it's observational. Here it is a study, but study word does not come here. It's called trial. That means you're trying something. It's study. That means you are observing something. That means you are observing something. That means you are observing something. Okay. Now what is prospective? What's retrospective? If you could just clarify these terms, your life will become much easier. Now I'll give you an example of the case control study. There was an effect that you noticed. You want to know its cause. Okay? For example, patient suffered from corona. You want to know from where did that coronavirus. You go do the case control study. You find its cause. It was caused by a Chinese lab. Like those are the things those are the rumors that are running in the environment. So just get the science. Effect, you found the corona cases, you found out its causes. Now come to the retrospective. You have the cause. You were working in a lab, you found a bacteria. Now you want to know how much destruction this bacteria can cause. You would do the retrospective cohort study. Cohort goes into future. Cohort goes into future. Case and control goes into past. Cross-sectional study. What? You take a population, you take a sample of the population and you do the study. That's in the present. That's called cross-sectional study. Now what is cross-sectional? You have 20 people. You took 2 people, you want to study on them. That's your cross-sectional study. You cross-sected the population. You took a piece out of the population. That's called the cross-sectional study. Simple. Now, what are the key points? What is the problem in case control study? That is retrospective. You go into the past. Retro means backward. You go into the past. What is the problem here? The problem is recall bias. People cannot tell you accurate history of what happened, when it happened, what were the conditions. The basic problem is recall bias. People cannot give you proper history. That's the problem here. Now, what are the advantages? It's cheaper. You just have to take history from the patient. Why the cohort study is expensive? Because you have to introduce that virus pathogen or treatment to the patient. You have to produce the treatment. You have to produce that virus or bacteria. You have to measure everything because it's about to going to happen into the future. Not like case control studies for which everything has happened. Now you just want to connect the dots, find the cause. That's the case control study. That's the retrospective study. Cohort can be retrospective, can be prospective. Now that's your task to read all those things. These are very simply written. Keep in mind, the case control in cohort are observational in nature. You are just observing. You are not measuring anything or any drug. If you are measuring anything, that would be called a trial. If you are measuring any drug dose, that would be called a trial. Now it's interventional. You are intervening something. Now that was my best how I could explain those little bit rough terms in my own words in the simplest way possible. Thank you for listening. That's all.